A breadth-first search goes broad to the neighbor nodes before going deep. It uses a queue. We add all of the children to the list and then pull from the list to check if it has a path. Say we start at node 3. Then we would visit nodes 1, 4, 5, and 6 on the second pass, since each of these are neighbors of node 3. On the third pass, the algorithm would visit node 2, which is not a direct neighbor of node 3. Now that we understand the concept of a breadth-first traversal on a graph, let's write the Python code to implement it. Let's create an adjacency list variable that we will set to an empty list. Don't worry about adding values to it for now. This is just to show you how you can perform a breadth-first search on an adjacency list. Then we will define a breadth-first search function that takes in one parameter named root. Inside of our breadth-first search function, we will have a variable named visited, set to an empty list. Then we will have an if statement that checks if root is not in the adjacency list. If that is the case, we will return visited. Then we will have a variable named nodes that we set to a list with root.value inside of it as the first element. While the length of nodes is greater than 0, we will create a variable named vertex, set equal to nodes.pop0. If vertex isn't visited, we will continue to the next iteration in the while loop. We will append vertex to the visited list. Then will come a for loop for I in range length of the adjacency list. We will create a variable named neighbor, set equal to nodes at I. If neighbor is not in visited, then we will append neighbor to nodes. Outside of the while loop, we will return visited. In the next lecture, we will learn how to perform a depth-first search on a graph in Python.